Okay, so now we're going to graph some cube root functions. The index is 3 for all 3 of these, so it's going to be a little bit different from the square root functions. The steps are basically the same. The beginning is different because we use a different table to begin, okay? Where a square root function is our table that we know very well, 0, 1, 4, 9, and 0, 1, 2, 3, for the x values and the y values. A cube root function has a different table, and it looks a little bit different, okay? So this is not for cube root, this is for square root. For cube root, this is the one you're going to use. So I'm going to write it here so that I can use it for all 3 of them, okay? For cube root, your table looks like this every time. You're not going to do 0, 1, 4, 9. You're not going to do 0, 1, 2, 3. In cube roots, we can have negatives. Negatives are okay in cube roots. So what you're going to have is negative 2, negative 1, 0, 1, and 2 for your y values. For your x values, just think what is the cube of those numbers. Okay, cube them, multiply them by themselves 3 times. So this is negative 8, negative 1, 0, 1, and 8. This is your cube root table. This is the one we're going to use. And if you look at what the graph looks like, it goes something like this. Okay, do a quick, easy graph. Actually, I'm going to do it here because it goes pretty far out. And my y-axis is right there. That should fit. Let's see. Negative 8, negative 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. Right there. Negative 1, negative 1. Negative 1, negative 1. There. 0, 0. 1, 1. And 8, 2. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Look what it looks like, okay? Goes like this, crosses through this point, goes up, and then it goes through that point. This part right here is sort of a square root function, not really, but it has that kind of shape, okay? And this is basically a rotation of this. If I take this and rotate it around 180 degrees, it will land on this place right here. So that's what your parent function looks like, which is y equals the cube root of x. That's the parent function, that's its table, that's its graph. We're going to use these to figure out what those look like. The steps are basically the same as square root functions. We just start with a different table. That's it. So here we go. Make a table for it and figure out what you need to do to your x values and your y values. Okay? Anything happening inside of the radical? No. That means that your x values are going to stay the same. Negative 8, negative 1, 0, 1, and 8. Anything happening outside of the radical happens to the y values. And yes, there is something happening. Nothing here to multiply by, but there's a minus 4 there. So what I'm going to do is I'm going to take every y value here and subtract 4 from it. So negative 2 minus 4 is negative 6. Negative 1 minus 4 is negative 5. 0 minus 4 is negative 4. 1 minus 4 is negative 3. And 2 minus 4 is negative 2. There it is. Looks like my y values are all negative. X values goes from negative 8 to positive 8 again, just like that one. So we do get these pretty long graphs. That should be good. They are here. 8, 7, 6, 5, 4, 3, 2, 1, 0. Here I'm going to put my y-axis. And then 1, 2, 3, 4, 5, 6, 7, 8. There you go. That fits perfectly. So just plot those points and you're done. Negative 8, negative 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Right here. Negative 1, negative 5. Negative 1. Negative 1, 2, 3, 4, 5, right here. 0, negative 4, 0, negative 4, 1, negative 3, and 8, negative 2. And there it is. It goes like this. Goes this way, hits that point, starts increasing, and then flattens out. These cube root functions exist in all directions, right? Remember, square root functions don't exist past this point, right? This is where they begin and they keep going forever. Cube root functions keep going forever in both directions. Why? Because it's the cube root, so we can have negatives. That's it. That's the one for 11. Now, number 12. Make your xy table. Take your parent function table and change it accordingly, okay? All right, now let's look at this. There's a couple of things happening here. First, there's something happening inside the radical. It says plus 1. That's a translation to the left, not to the right, to the left of 1 unit. So what am I going to do to my x values? I am going to subtract 1. So take all these x values and subtract 1. Negative 8 minus 1, negative 9. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. 1 minus 1 is 0. And 8 minus 1 is 7. So we got 7 from 8 minus 1. And now the y values. What's happening to the y values? My originals are negative 2, negative 1, 0, 1, and 2. But this is telling me to do a bunch of stuff to it. Okay. First, the negative sign in front of the radical tells me to take my y values and multiply them by negative 1. Or change the sign of it. Okay. Then this 3 could be in front, or it's the same thing as putting it out here. It's telling me to move it vertically up by 3 units, okay? So that's exactly what I'm going to do. I am going to first take these values and multiply by negative 1. So negative 2 times negative 1 is 2. So basically all of these become the opposite sign, right? So this is 2, and then plus 3 is 5. This 3 is the same thing as if it was out there. If that helps you see it a little better, maybe write it out there yourself, okay? Negative 1 becomes 1 because I'm multiplying by negative 1. So what I'm doing is multiply by negative 1 and then plus 3. 1 plus 3 is 4. 0 is 0. Plus 3 is 3. 1 times negative 1 is negative 1. Plus 3 is 2. And 2 times negative 1 is negative 2. Plus 3 is 1. Yes, there is a pattern there. Okay. So it looks like my x values start at negative 9. My y values, I need positive 5. So I'm going to draw my graph right here so that it fits. Starting here. If this is negative 9, negative 8, negative 7. So it's going to be another pretty long graph. Negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. That's what I need. And for my y values, I really only need positives. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Right here. And up like that. That's what I need. So negative 9, 5, negative 9 is right here. 1, 2, 3, 4, 5. Right there where I put my 3. Negative 2, 4. Negative 2, up 4. Right here. Negative 1, 3. Negative 1, 3. 0, 2. 0, 2. And 7, 1. 7, 1. And there you can see the shape of it. It goes from here, this way, downwards, and out. So it's the same as this one, except it got reflected. That's what happened. It got reflected. Okay. So it's a cube root function, but it got reflected. That negative 1 reflected. Now let's look at number 13. Last one here. I am going to erase that one. Okay, I have to erase it. So if you still haven't finished it, go ahead and pause before you continue. Okay, 13, same idea, xy values. Make an xy table right here. Okay, take your parent function table and change it accordingly. First, inside of the radical, it says minus 1. That means to the right 1. So I'm not going to subtract 1, I'm going to add 1. So from my values, negative 8, negative 1, 0, 1, 8, I'm going to add 1 to each one. Negative 8 plus 1 is negative 7. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And 8 plus 1 is 9. Y values. A couple of things are happening to the y values. I need to multiply first by 1/2. and then add 3. Times 1/2, then add 3. So negative 2 times 1/2 is negative 1. Times 1/2 means cut it in half, right? Negative 2 times 1/2 is 1/2. Is 1. Negative 1 plus 3 is 2. So times 1/2 plus 3 is what we're doing here. Times 1/2 plus 3. Negative 2 times 1/2 is negative 1 plus 3 is 2. That's how I got these 2. Do it again. Negative 1 times 1/2. That's negative 1/2. Plus 3 is 2.5. You could do that calculation on your paper or on your calculator if you're doubtful. 0 times 1/2 is 0. Plus 3 is 3. And yes, there is a pattern there. 1 times 1/2 is 1/2. Plus 3 is 3.5, which is 3.5. And 2 times 1/2 is 1. Plus 3 is 4. There you go. So what I need is a graph that has positive y values and mostly positive x values. Okay, so I'm going to start it here. This is going to be negative 7, and then I'm going to keep going this way. This is negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. So here's my y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. There, I fit every single one of the numbers that I need into my graph. So negative 7, 2, 0, and 2.5. Right there. 1, 3, 1, 3, 2, 3.5, 2, 3.5, and 9, 4. 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4. And there it is. What happened to the parent function to become that one? It got shifted up by 3 units. It also got shifted to the right by 1 unit. And also it got compressed by a factor of 1/2. Okay? So notice that it kind of got flattened out. And that's it for those 3.